Okay. So we will be using Anaconda. Okay, Anaconda Navigator. That's what we'll be using. Okay. So when you run that, you will see this screen, Anaconda Navigator. Okay. And then we will use Jupyter. Okay, so that's what we will be using. Okay, Jupyter. And when you click launch, that's going to open okay, so that's going to open okay, let me try it again. Okay, so that's going to open this page. Okay, this runs in the local browser, and you'll see the folders from documents. I think documents is the well, your PC is the default page, so you'll see that here, and then you can navigate to the other subfolders from the root folder, and then you'll be able to save stuff and open stuff. Okay, so that we'll look at it in more depth in a little bit. Okay, so this is the platform that we'll be using, Anaconda Navigator, and from Anaconda Navigator we'll use Jupyter Notebook. So we'll look at that in just a minute. But first, let's look at what we will be covering in this course. Okay, so this is Business Analytics 1. Okay, and then you have the description here, and we'll be preparing, importing, cleaning, preparing, and visualization of data for business analytics applications. Okay. So we will not be looking at applications in this class. It is the data that we'll be looking at, the data preparation part of the project, of the data analytics project. So that's going to be our focus, and we will be using Python. Okay. So we will use Python in this class, and then in 40 to 70, that's your spring semester modeling class, which is the business analytics applications, that I'm proposing to teach with R. So you'll get both. You'll get Python in this class, you'll get R in the next class. Okay, spring. All right. Okay, so when you look at data analytics project, okay, what does that involve? What does it consist of? Okay, so we start off from a business problem. Okay, there is something to be done. There is some issue that needs a solution. So you define the problem and define the objective. Okay, so that's where we start. So for example, we recently did a project, myself and Dr. Amity, about student retention. Okay. So now we have, especially after the recent past, there are students having, facing lots of difficult situations, issues, and students may not be able to proceed with their education, they drop off, and that's not a good thing for several reasons, of course. The most important reason being that we want to encourage everybody to succeed. And also, funding mechanism in the state, even if you look at it from a purely selfish point of view, from the school's perspective, every student that we lose, and we lose funding. Okay, so even if the more higher level objective of encouraging students is not sufficient, which should be sufficient by itself, but there is a economic incentive as well. So we wanted to analyze data, then see what factors will contribute students to persist in their education, and what students would catch the at-risk students early on, so we can encourage and help them succeed and not drop out. So that's your problem. So our problem is to collect data, analyze data, and figure out which students are at risk of dropping out, so that some kind of intervention, appropriate intervention can be implemented for the benefit of students and for the benefit of the university. So next step is to collect data. What kind of data that's available? Okay. There are institutional data that's going to be available. So whatever company, whatever the project may be, there is going to be data available within your own organization. Okay. Then sometimes data may have to be brought in. Suppose if you're looking at geographical distribution, and then the income and education level of different geographical tracts, say county-wise or district-wise. Now that kind of data is not going to be available in-house in your organization, so you have to get it from outside. Maybe sometimes you have to pay for it. Sometimes if it is government data, it's available for free. So we need to be able to get data from within the company, and if needed, data from outside the company, and then put them together, right? Somehow we need to, if you have students on the one side, and then we have, say, the school that they graduated from, and what is the funding level of that school, right? So now you have the external data, and then here from the internal data you have each student, the high school they went to, then you have the high school data coming from here, and you have to join them, and then for each student then you'll be able to tell what kind of school they came from, they graduated from. So now you're now combining data. So collect data now includes not just getting data from different sources. You want to link them, and then generate more useful and valuable data. Okay. And then once you have that, you need to explore and understand the data. Are there any problems in the data? Oftentimes data will be very messy. Okay. Rarely you will get data that is completely clean without having to do any modifications at all. Okay. So for instance, in our problem of student retention, we had student data, okay, student demographic data, okay, male, female, age, and whatever else that you have. And then you have student enrollment data, okay, what classes, which semester, what classes, what grade. Okay. And then we have for each class, we have which college that particular course is from. So that's the kind of data that is available. Now how can we tell? Now remember, what we are trying to do is to catch at-risk students, so that some intervention could be implemented. Okay. So now if this is the data that you have, okay, so you have demographic data, and then you have courses that the students have enrolled in, and then what colleges they are. And with this data, how can we tell whether a particular student is at risk or not? How do you tell? So there is no variable that is already there. There is no column which says this student is at risk or this student is not at risk. Okay. So how do you figure that out? So that's where you have to, we have to explore and understand, clean data, and then you have to prepare data. So you have to prepare, you have to somehow get that information from the data. So what we did was, now we see whether the student has graduated or not. So we had a column which says student graduated or not graduated. Right? So that's simple enough. That's a factual data. There is no trying to figure out whether a particular student is at risk or not. So that's one thing that we looked at. And then whether the student is enrolled or not. If a student has already graduated, then is the student at risk? No, the student is already gone. He's graduated, everything is good. Okay. Now if a student is currently enrolled, okay, now here is where, given the available data, how do we determine, there is some amount of judgment involved. What we did was that if a student is currently enrolled, okay, so then we're going to say, all right, so that student is fine. So a student who is graduated already, or student who is currently enrolled, they are not at risk. A student who is not graduated, okay, and not enrolled currently. So now we have to now write some sort of code which will go through this data. So you have student data, student enrollment data, then you have to go through that enrollment data and then prepare another data set or a column that will identify for each student whether the student is at risk or not. And at risk is if a student is not graduated and not enrolled and everybody else is okay. So you have to, so that's one very important example of what we need Python for. So you need to write the code in Python to do that, to create a new variable. Okay. And then when you explore the data, that you may end up with, okay, for example, you may end up with data that's kind of crazy. Okay, so we'll get to this in a little bit. So what we did was, okay, student success is funding dollars, and of course student helping students to succeed, that by in and of itself is a good thing. So the goal is to identify at-risk factors. So we have these three data sets: demographic data, student grade data, and course data. And then we calculated at risk. Then here are a couple of variables that I'm presenting. I'm not presenting the whole thing. It will take a lot of time. So we looked at grades, okay, and then here are the grade distribution. So we see A, B, C, D, F. That's good. And what is this I, O, S, and S, T? That not very many people will be familiar with that. So we have a situation like this. Now, what do we do with those? Do we just throw them out? Which may not be a big problem if it constitutes only a very small percentage of observations. Okay, you see there is not very many, but here this O is quite a large amount. Okay, so what we have to do is to figure out what these mean. So I is incomplete, so which means at some point in time it's going to get completed, so we can leave it as is, or maybe use some other way of handling that. And O, I don't know what that is, I don't remember. Yes, is satisfactory or not. So those are the kinds of things that, so you have to now figure out what to do with those. Okay, do we code it as, okay, maybe we can code all of this as other, okay, or some, so some judgment is involved. So you have to talk to the people. We talk to the institutional research folks and understood what those other grades actually are, and then I think we kept these two, and we got rid of these as unknowns. I don't remember exactly what we did. And then again, when you take a race, so you see you have so many different races. Okay, some of them are very, very small in number. So again, what do we do? Okay, do we keep all of them? Okay, there are some reasons why you don't want too many categories for a categorical variable. When we do that, you have what you end up with what is called dimensionality, where you end up with lots and lots of dummy variables. So we don't want that. So here again, okay, you look at each variable and then understand what the data contained in that variable represents, and are there any issues in the data, and then fix those issues. So another okay, so here clean and prepare. So these are the values that are problematic. Okay. Then there are cases where you will have missing values. Okay. So here is student data set. Okay. Student enrollment courses. Okay. So we have total 209,463 observations. Okay. Now, some of them, okay, look at the number of observations with valid values, non-null cases. Okay, I have not listed all the variables here. Okay, these, if you look at these three variables, then you see that not all of them have a valid value in these columns. So they are blanks. And that's another situation that you will face in many data sets. So you will have missing values. Now, what do you do with missing values? Do you just drop the entire? So if you see a missing value, just get rid of that observation completely. So that's one approach. That's not a good approach, because even if there is only very little, say 5% of the observations of the values are missing and they are distributed at random everywhere, and whenever you see just one missing value and you drop the entire row, then you may end up with just 5% to 10% of missing values. You may end up deleting 80% of the observations. Well, such situation is kind of extreme, but it could happen. So, so we have to do something about the missing values. Yeah? And there are ways to handle missing values that are called imputing missing values. So that's another thing we need to know how to do. And we do that in Python. Okay, so there are some procedures available, functions. We use those functions to deal with those situations. So again, we will be talking about more about these missing values later on. Okay, transform data. Okay, so there are instances where you may want to use logarithmic or power transformation. So here, if you look at variable here, okay, this is frequency distribution, and you see that most of the values are concentrated in this one range of values. This is a histogram. Okay, the x values, the value of the variables are here, and this is your frequency. Most of the observations are are clumped together here in this little area, and then very little on the rest of them. Okay, so now this is a problem, not in all of the classification models that we'll be using, but there are models where this is the problem. We can't have a distribution like this, which will not give you very good results. So if you take a logarithm of these x values, then you see that it gets distributed more evenly. Okay. So transformations like that, you need to be able to do. That's another data preparation task. Okay. Another is, if you have a continuous variable, you may want to put them into bins. There are procedures that require variables to be in, right? So age, for example. Okay, so below 20 is one group, 20 to 25, 25 to 30. So you're binning the values into these classes. Okay, again, that's something that we should be able to do in the data preparation. So here are some of the some examples of what kind of transformations that we may have to incorporate. So logarithmic transformation or Box-Cox. Box-Cox will be power. You raise values to a power, maybe a square root or maybe 2/3 or whatever, And then normalized means values that, or if you have multiple variables, okay, some variables, the magnitude or the variables are in thousands, tens of thousands. So for example, salary in annual income, okay, so you're going to have that in tens of thousands and hundreds of thousands. And then you have age will be what? Somewhere in the double digit only, right? Very rarely you're going to get up to the 3 digits. So they are magnitude-wise, they are very small values. Now there are some models, okay, where this will be a problem because the variable with large magnitude will overwhelm variables with small values. So we have to bring all of the variables into the same playing field, if you will. And that is what is called normalization. So you can, there are several ways to normalize. One popular way is to convert values into number of standard deviations. So you take a value, subtract the mean, divide by standard deviation. So you are now converting the values into number of standard deviations away from the mean. So all the variables will now be somewhere between -3 and +3. So there won't be any magnitude based biases in the model. Okay. So that's another thing that we need to do. Then we have ordinal to numerical. So you have ordinal variables. Now remember, there are 4 types of variables that you can have. They are grouped into like nominal, categorical and numerical. Categorical, there are 2, nominal and ordinal. Okay. Nominal will be where there is no ordering, okay, like majors here. Okay. Major, marketing, finance, management, they are different majors. There is no ordering of which one is better. Maybe some of you have that in your in your own mind, but generally speaking, there is no ordering there. Because if you look at your grade A, B, C, D, that's also category. Okay, but there is an ordering there. Okay, when you have ordering, that is ordinal, nominal and ordinal. So those are categories. So nominal, ordinal category variables can be converted into numerical by assigning a number to it. So A is 4, B is 3, C is 2, D is 1, and F is 0. Okay, so that's a ordinal to numerical conversion. Okay. And if you have nominal, you cannot convert nominal into numerical values because numerical values, by nature, there is an ordering there. So you cannot take a nominal variable which is not ordered and then force it into an ordered set of values. So you have to create what are called dummy variables. So these are the kinds of transformations we should be able to do, which we will do. At the end of this course, you'll be able to do all that. So these are the things that we are looking at. Okay, let's see some more. Okay, at risk, I already talked about this. Okay, so now in a data analytics project, okay, if you look at the amount of time and effort that we need to spend on a data analytics project, okay, so this is what it will look like. So the data preparation will constitute about 80% of your time and effort. Most of your time will be spent on that. And once you have the data all prepared, cleaned, and ready for analysis, then the rest of the task really is quite smooth, and you need only 20% of your time is required for doing actual data analysis and writing a report. So data preparation is probably the most important stage of a data analytics or business analytics project.